Now we're going to take a look at how we can change a quadratic function from intercept form or vertex form into standard form by multiplying together algebraic expressions. Excuse me. One method for multiplying expressions containing two terms is to FOIL. Using this method, you add the products of the first terms, the outer terms, the inner terms, and the last terms together. You may recall having done this in Algebra 1, and the first terms are these guys. So if we were to multiply together the first terms, and I like to draw these arcs to show what I'm multiplying. If I do x times x, I have two x's in the product, so I have to show that's x squared. Now I'm going to go ahead and multiply the outer terms. The outer terms are the x and this 5. If I multiply the outer terms, I'm going to do x times positive 5. That would be a positive 5x. And now I'm going to multiply the inner terms, which would be this guy and this guy. If I multiply these together, I'd get positive 3x. And now I'm ready to multiply my last terms. That would be the 3 and the 5. So I'm going to do 3 times 5 and get positive 15. Once you're done multiplying every term in one binomial to every term in the other, you can combine like terms if possible. There is nothing to add with the x squared, so I'm just going to copy the x squared. However, I do have the 5x and the 3x, which are like terms, making a grand total of positive 8x's. And that takes care of those guys. And then I have just a plus 15. Notice this is in standard form. Oops. Standard form. Let's do one more example before we try a different one. Let's write this guy in standard form. By the way, you should note that this form is intercept form, and we're going to try to convert it into standard form. Before I do anything else, I always like to multiply together the two binomials by FOILing first, and then I'll take care of that too lastly. If I multiply together the first terms, that's going to be an x times x, that's going to be an x squared. Then I'm going to do an x times positive 3, that's positive 3x. If I do the inner terms, I'm going to have a negative 2 times x, that's negative 2x. And then I'm going to do negative 2 times the positive 3, which is going to be negative 6. If I combine the like terms, I'm going to end up with an x squared plus 1x minus 6. Now remember, I was supposed to multiply everything by a 2. So I'm going to put that 2 out in front, and I'm going to distribute that 2, or multiply it to each term in that trinomial. So if I do that, I'm going to end up with a 2x squared plus a 2x, and then 2 times negative 6 makes negative 12. Now we are done. We've converted into standard form. Let's take a look at one more example. If you take a look at this guy, this is not standard form. It's not intercept form. This is vertex form. Pretty easy to graph from vertex form, but we want to convert it to standard form for this example. Now this is something where a lot of students will make some mistakes here. First thing you need to do is convert this binomial squared into the product that it stands for. So what I mean by that is I have a 2 out in front, and x minus 3 squared is x minus 3 times x minus 3. There's really two x minus 3's being multiplied together in that expression. And then I'm going to copy down the plus 4. By the way, do not do what a lot of students will do, and they'll say, ooh, I can just like square the x and get x squared, and then I'll square the negative 3 and get, that's really x squared plus 9, Mr. Schultes. And you're going to get this wrong. As you'll see in a second, if you actually multiply out these two binomials by FOILing, you will not get that same expression. So don't do that. Let's carry this out. Basically, I'm doing the same thing I did in the last example. I'm going to FOIL these two binomials out first by doing x times x. I get an x squared, x times negative 3, minus 3x. If I do the inner terms, I have another minus 3x. And then the last terms, negative 3 times a negative 3 is going to be a positive 9. Now remember, in front of this I'm multiplying everything by a 2, and on the back end we're adding a 4. If I add the like terms in the parentheses, I have 2 in the front, x squared stays, but negative 3x minus 3 more x is a negative 6x. Then I have the plus 9, and then I'm copying down plus 4 on the end. Notice how this trinomial x squared minus 6x plus 9 is not the same as x squared plus 9. I'm missing that negative 6x term. So once again, here you want to make sure to not do this. Please do not just square the binomial. Let's go back to the problem at hand. I'm going to distribute the 2 now to each of the terms in the trinomial and get 2x squared minus 12x, and then 2 times 9 is positive 18. Now I can tack on that plus 4, and the last thing I'm going to do is combine those like terms and get 2x squared minus 12x plus 22, and we are in good shape. Thanks for watching.